So now that we have already established our balanced equation, we can now try to solve the first question, which is the identification of the limiting and the excess reagent. So to do so, we need to convert all of our masses of reactants into mole. To do so, we need to divide each of the masses with their respective molar mass. So for copper chloride, the mass, which is 15 grams, is divided by the molar mass of copper chloride, which is 134.25 gram per mole. And we end up with this result. Doing the same thing for sodium nitrate, we divide 20 grams by the molar mass of sodium nitrate. We end up with these values. So after getting the moles of the reactant, we can now proceed into the table. We have this table wherein we have 3 rows. We have the initial, the change, and the final. Okay. So these are the moles which we were able to calculate earlier. Okay. And we put them under their respective substances, okay, or respective columns. And we put in 0 for all the products. Since it's not stated that we have an initial amount of product, then we need to put 0 here. Okay. So after converting everything into mole, we need to find which is the limiting reagent. And to do so, remember that our first step is to um, take a reactant and assume that it will be consumed completely. So for example, we will, by trial and error, we arbitrarily chose sodium nitrate. So if we want to consume all of the sodium nitrate, then how much copper chloride would we need, okay, to consume this completely? So to do that, we divide our basis, which is 0.235294 mole. We divide it by the coefficient of our basis, which is 2 for sodium nitrate, and multiply it with our desired quantity. So this is why we have this set up here. This one, which is our basis, divided by the coefficient under uh, from which it belonged to, and then multiply it with our desired quantity. Okay. So by doing so, we end up with this amount. However, when we try to actually subtract these values, initial minus change, you'll end up with a final value or final number of moles for copper chloride, which is negative, and that is forbidden. Because in a chemical reaction, of course, it can only be 0 or you have something which remains. So by arbitrarily choosing sodium nitrate, we found out that sodium nitrate should not be our basis because we'll end up with a negative final value for copper. So we redo it, okay? We redo it, and now we remove all the previous calculations. We still start with our calculated ones. But this time, we'll start with the copper chloride. So we'll assume that all copper chloride will be consumed completely, become 0. And then we need to find the equivalent number of moles for sodium nitrate that would be needed to consume this completely. Okay, so same thing. This is our basis. And then we divide it with its coefficient, which is 1, and multiply it by the coefficient of our desired quantity. So by doing so, we'll end up with these values. And if we try to subtract the initial and the change for sodium nitrate, we'll end up with this value here. Okay. So if we use copper chloride as our basis, we'll get one reactant which becomes zero, and the other reactant would still have some moles left. And since there's no negative value here, then we would conclude that this is what happens, okay, ideally. So the reactant which is consumed completely would be our limiting reagent, which is copper chloride, and the one with some moles left would be our access reagent, and that would be sodium nitrate.